right, welcome once again. It is Ishola Adedeji Mike. All right, it's success enlightenment, and we continue our trigonometrics what studies in on success enlightenment. All right, we've already established what is trigonometry. We've already established what is trigonometric ratios, and now we've also already established the uses, relevance, applications, importance of trigonometry. Now, in this video, we're going right straight to the most important topic and subtopic in trigonometry, which is what? The trigonometric ratios. These ratios are what you'll be doing in the corpus of about 3, 4, 5, 6, 7, 8, 9, 10 videos. All right, and that is what is even important, is expected of you to have a mastery of as far as trigonometry is important. Okay, this is not to say the earlier video is not important. It is important. All right, you have to have the this is a prerequisite to this. Let me put it that way. Okay, now here in this video I'll be covering these three major aspects of what trigonometric ratios. I believe we what the basic trigonometric what ratios, right? And from this we have some reciprocal. So after that I'm dealing with what the reciprocal of these basic trigonometric ratios, and also there are some basic relationship between the what these trigonometric ratios and their reciprocals. So I'll be covering the relationship between the basic trigonometric ratios and their reciprocal. Trust me, it's going to be a very fun one. So just stay tuned. Know at the back of your mind, at the end of these videos, you must have a mastery of the word of the basic trigonometric ratios, and know their reciprocals, and know the relationship between the basic trigonometric ratios and their reciprocals. See how it is. It means if you know these basic trigonometric ratios and you know the relationship between this the basic trigonometric ratio and the reciprocal, it means you can always find this even though you don't know this. Okay, it means now if you know this and this, if you don't know this, then you can find this, right? That's what it means. That's how sweet this is. You don't get it yet, don't worry. Let's get right into it. You understand it. The basic trigonometric ratios, right? In trigonometries we have three major basic ratios, and these are the sine, the cosine, and the what? And the tangents. These are the three basic trigonometric ratios. We have the sine, the cosine, and the tangents. All right. But in definition of these ratios, we have three major approaches to the definition of these ratios. We have the traditional definition or approach, and we have the alternative approach. All right, we have the traditional definition approach and we have the alternative approach. In your basic understanding from your secondary school, almost every one of you already knows the traditional definition. Traditional definition, we are talking of what we popularly know as what? So ka tua, where x is sine, c is cosine, and t is what? Is tangent. O is what? Opposite. H is what? Is hypotenuse. And what? A is what? Is adjacent. All right. So this is what the traditional definition of what? Of basic trigonometric ratios. You already know this. Is what you guys popularly use as so ka. So many of you use this in passing your WAEC, right? Okay. So now the point is, I just come here and I write this. Don't forget, I'm already treating this now. Okay, I'm treating this now. You take this word later. Okay. Many of you, I just write here traditional definition. So katua, sine, cosine, tangent, opposite. Now the question is, what is the opposite? What is the hypotenuse, and what is the what? Adjacent? Because it's still grammar, and this is mathematics. It's less of what? Grammar. So given a triangle, don't worry, don't forget trigonometry. We are doing what? Triangle. Give me a triangle like this. Let me clean this part. Let me take this off. We're already dealing with sine, cosine, and tangent. That's our basic trigonometric ratios. You could be asked anyway, what are the basic trigonometric ratios? You are not thinking. It's sine, cosine, and tangent. Simple. All right. Given the triangle like this, okay. Let this be our A, let this be our B, let this be our C. Don't forget, this is what I did earlier, where I said this will be what? Capital letter A degree, this is capital letter B degree, and this is capital letter C degree, and this is small letter C, small letter B, small letter A. I've already explained this. Alright, but when our trigonometric ratios is concerned, we are dealing with a what? A right angle triangle. This is not a right angle triangle, okay? So what we do here is what? We form a right angle triangle. You can form a right angle triangle like this. So therefore, we have a triangle like this, a right angle triangle like this. Still the same edges. Let's say we have A, B, C. Okay? We have A, B, C. Don't forget, this will be a what? This will be a right angle triangle. This will be a right angle triangle. This, let's call this what? Let's call this theta, since we don't know it. And let's call this what? Alpha, since we don't know it. Okay? Don't forget, I told you the alpha and theta, they are used to denote the what? The unknown what? Angles of a what? Of a triangle. Right? This is a right angle triangle, right? So this here we what? Will be side A, the opposite side to what? To angle A. Don't forget, this is as angle A. This is what? Side C, small letter C, and this is what? Size B. Are we together? Yes, we are. All right. This is a right angle triangle, and from right angle triangle now we can develop what? Our basic trigonometric ratio using what? Traditional definition of what? So, so. Now the first thing you have to understand is what? What is an hypotenuse? Right? By definition, an hypotenuse, what it means is what? Is the longest side of a right angle triangle. The longest of all the three sides. Don't forget, a triangle has three sides, and these sides are hypotenuse, opposite, and the adjacent sides. Alright, and of all the sides, the longest side of a right angle triangle will always be the what? The hypotenuse side, and that side is what you should first identify, which is what? This. If you look at this and this can never be as long as this. This is what? This is a diagonal. This is a diagonal, and in any shape that is forced, the diagonal will be the what? The longest side. The longest side. So which is it as what? The hypotenuse. This C here is what? Is the hypotenuse. Is the longest among all these three. Okay. Should in case that you are given that the sides of a right angle triangle are what? 2, 4, and 7. You don't need to crack your brain. Automatically you know that 7 is the longest. So automatically 7 will be your what? Your hypotenuse. Do you get that? So hypotenuse is the longest side of a what? Of a right angle triangle. Now once you have found your hypotenuse, you are left to find your what? The opposite and the what? And the adjacent. Now leave the adjacent, focus on the opposite. Now the opposite is not fixed. The opposite sides could be this or this, depending on the what? On the angle you are calculating. Right? If you are focusing on what? On sin theta or cos theta or tan theta, like this, if you are focusing on angle theta, now the opposite to sin theta will be what? Will be B. The opposite to angle theta is what? Is the side that is directly facing what? The unknown angle of what? Of concern. Now, but if you are focusing on what? Angle A, which is angle alpha, alright, the opposite side will be what? Will be A. You are not getting it now. For instance, let's say I'm dealing with sine and I want to find what? Sin theta. The opposite in this will be what? Will be what? Will be B. This will be the what? The opposite side. But should in case I'm focusing on what? Sine alpha, the opposite will be what? Will be A. Alright. What the opposite directly implies is what? Is what sides? What side is directly facing the angle that you are what? You are concerned about, that you are trying to estimate, that you are trying to find. Which side is what? Is focusing on them. And if you are with this will be your opposite. And if you are dealing with this will be your opposite. Don't forget, the sides of the triangle, they already what? They are 3. And you've already know your hypotenuse, you've known your what? Your opposite. So the last side will be what? It will be your what? It will be your what? Your adjacent. Okay? The last side will be your what? Your adjacent. Now, this is your opposite, this is your what? This is your what? Hypotenuse, and this is what? The adjacent. The adjacent is what connect the what? The hypotenuse to the what? To the opposite side. Is that gap that connect the what? Your hypotenuse to the what? To the opposite side. So it is always the last, the other side. Alright. If you look at this is what? This is your hypotenuse. This is your what? This is your opposite. So now what connect this hypotenuse to your opposite is your what? Is your adjacent. Is your adjacent. Is the base. Is your sitting ground. Do you get it? That is your what? That is your adjacent. Now, once you've identified this, so the traditional definition tells us that what? The sine of an angle is equals to what? The ratio of the opposite side and the what? And the what? And the hypotenuse. Right? While the cosine of an angle is equals to what? The ratio of the adjacent side and the what? And the hypotenuse. While the tangent of an angle is the ratio of the what? Of the opposite side and the what? And the adjacent. You don't get it? Alright, fine. Let me take it one after the other. Let me make it more simplified and we get it once and for all. Don't forget what we are dealing with. What is trigonometric ratio, basic trigonometric ratio, and we're focusing on the what? The traditional definition. The traditional definition. Alright? Given, let's say we are given a right angle triangle. You can write like this, or you write it in full. Given a right angled triangle like this. Don't forget this 90-degree. This our A, this our B, this our C. This angle is unknown, we call it angle theta. This angle is unknown, we call it angle alpha. Okay, this will be what? Small letter A, this is small letter C, and this will be small letter B. Alright, so now we are looking for our three basic ratio, which is our what? Our sine, our cosine, and our what? Tangent. Okay, sine is denoted as what? Sn. Cosine is denoted as cos. While tangent is denoted as what? Tan. Okay, this is how you represent them. This is the shortcut for sine. When you see sin, we are not talking about sin in trigonometry, we are talking about what? Sine. And when you see cosine, when you see cos, we are talking about what? Cosine in trigonometry. And when you see tan, we are talking about what? Tangent in what? In trigonometry. So now, by traditional definition, what traditional definition that is that focusing on angle theta, focusing on angle theta. By traditional definition, sin theta is what? Is the ratio, that is the ratio of the opposite sides to theta divided by what? The hypotenuse side of theta. That is what? Traditional definition. Traditional definition of sin theta is what? The opposite side of theta, of angle theta, which is B, equals to what? Divided by the what? The hypotenuse side of theta, which is what? C. This what sin theta is. But suppose you are dealing with what? Sin alpha. Sin alpha. But traditional definition bar, sin alpha will be the ratio of the what? Of the opposite side of alpha divided by the what? The hypotenuse side of what? Of alpha, which is what? The opposite side of what? Of alpha is what? Is A. And the hypotenuse is what? Is C. Do you get it? It's as simple as that. The opposite side of the angle divided by the hypotenuse side of the what? Of the triangle. So do you get it? That is what? That is what the traditional definition says about what? Sin theta. Okay? This is traditional definition of what? Sin theta. Now, let's deal with what? Traditional definition of what? Here we explain what? Theta, angle theta, and what? Angle alpha. Alright, now let's deal with what? Cosine. Okay, what is traditional definition of what? Of cosine. Now, the definition of cosine is very, very simple. If you still remember your SOHCAHTOA, it's still the same thing. So, what's dealing with what? Cos theta. Let's see angle theta here. By traditional definition, but what it says that what? Cos theta is equal to what? The ratio of the what? Of the adjacent side of theta divided by what? The hypotenuse side of the what? Of the right angle triangle. Let's put it like this. This is as what? This cos this theta. So the adjacent side of theta is what? You know this hypotenuse, this opposite. So this has to be the what? The adjacent, which should now be what? A divided by what? C. Are you together? Are we together? The adjacent side of what? Of theta divided by what? The hypotenuse side of the right angle triangle. If you are dealing with what? Cos alpha, by traditional definition, what cos alpha stands for is what? Is the what? Ratio of the what? Of the adjacent side of what? Of alpha divided by the hypotenuse side of the what? Of the right angle triangle. That is the adjacent side of what? Of alpha divided by what? The hypotenuse sides of the what? Of the right angle triangle, which is same thing as what? This alpha, this is opposite, this must be the what? The adjacent, that is b over c. And this is the traditional definition of what? Of cosine theta and alpha. This is traditional definition of what? Of cos. Do you get it? Very, very simple. Now let's deal with what? With tangent. Let's deal with what? Tangent. Let's deal with tangent. What does it have to say with what? With tangent. Don't forget, tangent is as what? Tan. So your tan theta, by traditional definition, will be the what? Ratio of the what? Of the opposite over the what? The adjacent. That is, tan theta is equals to what? The opposite side of what? Of theta all over the what? The adjacent side of what? Of theta. Now opposite over the adjacent, this theta, the opposite is what? Is b, and the adjacent is what? Is a. Don't forget, this is what? The hypotenuse. All right. Now if you are dealing with what? With tan alpha, the opposite, the definition is what? The opposite side of what? Of alpha all over the what? The adjacent of what? Of alpha, which is same thing as what? This alpha, this opposite, this hypotenuse, this is what? This will be the what? The adjacent, b all over the opposite, which is what? Which is a. Okay, which is, sorry, this will be the opposite. The weight of alpha, sorry, the weight of alpha is what? Is a. Okay, why the adjacent is what? The weight of alpha, yes, is a. Why the adjacent is what? Is b. Do you get that? The opposite of theta here is b, while the adjacent is what? Is a. The opposite of alpha here is a, while the adjacent is what? Is b. Don't forget, c is a what? Is our hypotenuse. And this is what? Is the traditional definition. This is the what? Is the traditional definition. So with this traditional definition, you can solve so many trigonometric what? Problem. All right. How do you use the traditional definition to solve so many trigonometric problem? Let me quickly make some certain illustrations before we go into the what? Into the alternative what? Definitions. All right. Let me rub this. Suppose we are given a right angle triangle like this. You are given this. Okay, we are given a, b, c, and we are given this to be what? To be 4, this to be 2, this to be what? 1. Okay, this definitely 90 degree, and this is what? Theta, and this is what? Our alpha. Now from here we can find our what? Sin theta. Don't forget, our sin theta is what? Opposite sides to what? To theta over the what? Hypotenuse of the what? Of the right angle triangle. Now the opposite side to theta is what? Is 2, and the hypotenuse is what? Is 4. Abi, this means that sin theta equals to what? 1 over 2, which is as what? 0.5. Now what is now angle theta? Angle theta will be what? As sin theta of what? 0.5, or as sin theta, as sin, sorry, 1 over 2. All you simply do here is what? Is you press your what? Your calculator for what is what? As sin 1 over 2. Okay, you press your calculator for what? As sin 1 over 2. and that's what the angle we give you will be what will be theta. The angle we give you what is theta. And when you press your calculator for r sine 1/2, what do you have? You have your what? Theta should be what? Theta to be what? 30 degree. Theta should be what? 30 degree. Do we get that? Now suppose we are focusing on what? Sine alpha. Alright. The sine alpha, still the same way. The opposite side is what? Is 1. Right? The opposite side will be 1. And what? The hypotenuse side will be what? Will be 4. The hypotenuse side will be 4. So what do you do from here? This, you said alpha will now be what? R sine 1/4. When you say R sine 1/4, when you press on your calculator, what you are going to have is what? It will be 60 degree. It will be 60 degree. And by this, with this knowledge, you don't have any of this angle. You have this to be 90 degree. All you have is this size 4, 1, and 2. Alright. With this 4, 1, and 2, you can use the word traditional definition to find each of these what? Angle of a right angle triangle. Suppose you are not looking for, you are not using sine. You are not using a sine. Then you want to use what? Cosine, right? So cos theta here is what? Instead of opposite over hypotenuse, we usually what? Adjacent, which is what? 1/4. Which is what? 1/4. Alright. When you say theta, it will be what? Arc sine and arc cos 1/4. This will give us what? 30 degree. This will give us what? 30 degree. Also for the alpha, so this is what? Cosine of what? Alpha, which is what? The adjacent of this is 2, and the hypotenuse will be 4. That will now be what? Alpha will now be what? Cos raised to minus 1, which is the arc cos 1/2, which is as what? 60 degree. Do we get it? It's as simple as this. It's as simple as this. The same thing for tan. You can do the same thing for tan. So you can apply this traditional definition of what? Sine equals opposite over hypotenuse. Cosine equals to what? Adjacent over hypotenuse. And tangent equals to what? Opposite over adjacent. When you have all the sides, or at least 2 of the sides. When they give you 2 of the sides, and you have to find what? The angles, you can apply this method. So you can apply this traditional definition in solving trigonometric problem when you can apply this traditional definition in solving trigonometric problem when, number 1, when you have what? At least 2 known sides. At least you need to know at least 2 of the sides. And what you use traditional definition to find basically is what? Is the angle. The angle of the what? Of a of a right angle triangle. But suppose you are given the angle. Suppose you are given the angle. When you are given any one angle, when you are given any one angle and one side, then you can use it to what? To find the other side. Then you can also use it to find the other angle. So you can only apply this when you have these 2 available for you. Don't forget, you see, as you study further, you realize that even though you understand it, you just need to know when you can use it. Right? It's not just important that you have cutlass and hoe. You must know when you get to the farm where you can use the cutlass and where you can use the hoe. So you won't end up using the cutlass where you should have used the hoe. You'll be wasting time. Okay, so simple for you to use this traditional approach. For you to use traditional definition, you can use it when you have at least 2 known sides, no angle known. Or when you have at least any one angle, they give you any one angle and what? One side. Okay, don't worry, I will take my time. I will write a series of questions. I will solve them using what? Traditional definitions. But I won't just do that. I will solve them also using the other definition. Do you get the other definition? So I will solve all together. So for this is what you must know. Okay, and by this we come to the end of what? Traditional definition of what? Trigonometric what? Ratio. Now we are going to consider the what? The alternative what? Definition of what? Trigonometric ratio. All right, we get to the alternative definition or alternative approach to basic trigonometric ratio. All right, the basic thing is that the alternative definition uses what, the knowledge of what, coordinates, that is the quadrants, to actually present the what, the relationship. What do you mean what, quadrant? Definitely we call this in trigonometry, we name this what, the first quadrant, or positive. This is y axis, this is your x axis. All right, this is your y, this is your x. All right, so this is a positive quadrant because both here is positive and both here is what, is positive. When you get to this place, here is positive, here is negative, this is second quadrant. And when you get to this place, here is negative, here is negative, this is what, third quadrant, and here is what, the fourth quadrant, negative and what, and positive. All right, and this is just like a graph. All right, that's a quadrant of a coordinate. So basically, using the first quadrant here, I will further explain this in further discussion in this still same topic. All right, but to make it simple, I label this A and B. All right, the B here, B here will be a coordinate of what, x and y, because this is what, this x, and this is what, this is y. Okay, this is x, this is y. So the alternative definition still drawn on the what, on the traditional definition, because this is sin, this is theta. If you are concerned with sin theta here, sin theta here, we still drawn on what we've already know, which is what, the opposite over what, hypotenuse. Okay, the opposite over the hypotenuse. And if we are looking for cos theta, it's still drawn on what, which is what, the adjacent all over what, the hypotenuse. And if you are looking for tan theta, which is what, the opposite over the what, the adjacent, is still drawn on what we have already know. But majorly about what the alternative definition, what it really present to us, is what we call the what, the Pythagoras theorem. This is the major addition, that this alternative definition, this is what it presents to us, and this makes it very, very convenient for us to find all the sides and all the angles of what, of a right angle triangle. What's the Pythagoras theorem? The Pythagoras theorem said that the square of the hypotenuse sides of a right angle triangle is equals to sum of the square of its other two sides. Now, what are we saying here? This is the hypotenuse. That is the hypotenuse side. The hypotenuse side square is equals to what? The square of the what? The opposite side square plus the what? The adjacent side square. This is what? Pythagoras theorem. And that is major, this is major addition, that this alternative definition, this is what it presents to us. That is 1 square is equals to what? Y square plus S square. Don't forget, here is our hypotenuse, here is the what? Is our adjacent or opposite, depending on the angle we are focusing on. But here we are focusing on what? On theta, because we don't put anything here, which means we are not concerned about this. So here, this is our adjacent square, and these are what? Opposite square. Do you get it? That's Pythagoras theorem. Now with this Pythagoras theorem, if you are given any two sides, you can find the other side. And once you can find the other side, you can always apply your traditional definition to find what? Any of the angles. So you can always use this alternative definition and the what, and the traditional definition to find all the sides and all the angles of a what, of a right angle triangle. Now quickly, before I go into solving, let's take the what, the reciprocals of these basic trigonometric ratios. Let's deal with the what, the reciprocals. Now when we talk about the reciprocals, when we talk about reciprocal in mathematics, if you are given 5 and you have to find the reciprocal of 5, what they mean is what? Don't forget, 5 is the same thing as 5 divided by 1. So the reciprocal of 5 will be what? 1 over 5. Okay, I want taught a class where I ask the question, can somebody give me the reciprocal of 3? And all of them, they are saying the reciprocal of 3 is what? Is minus what? 3. This is wrong. All right, this is what? This is wrong. The reciprocal of what? Of 3 is what? 1 over 3. And that's why majorly in division, fractional division, when you have 4 divided by 1 over, let me not use 1, divided by 3 over 2. So what you do is what? You change the division to multiplication by multiply it by the reciprocal of what? 3 over 2. That is, you now turn into 4 times what? 2 over 3. This is what? Knowledge of what? Of reciprocal. Reciprocal change the division to multiplication, then you multiply by the what? The reciprocal. So reciprocal of what? Of 1 is what? Is what? Is 1 over 1. Because 1 is 1. So you are alternating, but reciprocal of 2 is what? Is 1 over 2. Because 2 is equal as 2 over 1. Do you get it? So that's just reciprocal of anything is that thing divide, use that thing to divide 1. That is 1 divided by that thing. Reciprocal of anything is 1 divided by that thing. It's as simple as that. So in this scenario, we want to find the reciprocal of this our basic trigonometry identities. Don't forget, you already know that we have 3 basic trigonometry identities, which are what? Which are sine, cosine, and what? Tangent. Short for sine, short for cos, and short for what? Tan. So now the reciprocal of sine will be what? It will be 1 over sine. The reciprocal of cosine will be 1 over cosine. And the reciprocal of tangent will be what? 1 over tangent. Same thing as 1 over sine, 1 over cos, and 1 over tan. So when we are dealing with the reciprocal of this basic trigonometric identity, this is what we are talking about. What is the reciprocal? That is 1 divided by the initial basic trigonometric identity. And for each of these, we have the name we call them. So 1 over sine, which is the reciprocal of what? Of sine is what we call what? We call it what? Cosine. Okay? Now 1 over cos, let me use their short form. Which is the reciprocal of what? Of cosine, we call it what? Secant. And 1 over tan, which is the reciprocal of what? Of tangent, we call this what? Cotangent. Okay? We call it what? Cotangent. Cotangent. Sorry, this is cosecant. 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 We call this one what? Secant, and we call this one cotangent. And these are their reciprocal. So whenever they ask you what's the reciprocal of sine theta, what's the reciprocal of what? Sine theta. Reciprocal of sine theta will be what? 1 over sine theta, which is empty as what? Cosecant theta. Are you with me? Now, if you are asked what's the reciprocal of what? Of cosine or cos theta, is empty as what? 1 over what? Cos theta, which is empty as what? Secant theta. Okay? When they ask you what the reciprocal of what? Of tan theta, it's empty as what? 1 over tan theta, which is empty as what? Cotangent theta. Okay? Cotangent theta. You can write this short form. We call this one cosec. You can call this one what? Secant, and you can call this one what? Cotangent or cot theta. This is their short form. All of this connote what? Reciprocal. Cosecant is reciprocal of what? Sin theta. While secant is reciprocal of what? Cos theta. While tan theta, while cot theta or cotangent is reciprocal of what? Tan theta. Is just the reciprocal 1 over the initial basic ratios. All right, I believe this is well understood, and by this I've already shown you the relationship between the what? The basic trigonometric ratios and the what? And the reciprocals. How have I shown you? It means that if your sin theta, let me rub here. Okay, if your sin theta given a right angle triangle, like this, this is theta. Let's use just theta. Let this be A, B, C. Let's change this to A now. This is C and this is B. So now here Your sine theta will be what? This is your opposite, which is A, all over hypotenuse, which is C. Okay, now what will now be your what? Your cosec theta. Don't forget, cosec theta is what? Is 1 over sine theta. Okay, which is empty as what? 1 divided by what? A over C, which is empty as what? 1 times C over A. Therefore is equals to what? C over A. Okay, which means your cosec, your cosec theta will now be what? It will be your what? Your hypotenuse divided by the what? The opposite. Okay, is the what? Is the reciprocal of this. That is, it will be what? C over A. Do you get that? That's the relationship between what? Sine theta and cosec theta. The relationship between sine theta and cosec theta is what? Is what? Is this. Now the same thing. What is the difference between what? Between what? Cos theta and secant theta. Don't forget, secant theta will be what? Cos theta here will be, sorry, cos theta here will be what? Will be B over C. But secant theta is same thing as what? Equals to 1 over cos theta. It now be equals to what? C over B. The reciprocal of what? Cos theta. The same way, if you're giving what? Tan theta here will be what? Will be opposite, which is A, over what? Adjacent, which is B. Now cot theta, which is cotangent of theta, is the reciprocal of tan theta, and this will now be what? B over A. You see how simple it is? So this is the relationship between the what? Between the basic trigonometric ratio and their what? Their reciprocal. Other things you need to know is be what? Trigonometry's identities. What are trigonometry's identities? Trigonometry's identities, these are already established trigonometry's algebras. Such as you have the popular one, arguably the most popular one, which is what? Sine square theta plus what? Cos square theta is equal to 1. Arguably the most popular one. These are trigonometry's identities. Whenever you hear identities, it means already proven facts. They are basically used for trigonometry's algebra. It doesn't change. It is always a fact. It doesn't change. It is always a fact. Do you get it? Those are trigonometry's identities. Now I will do a separate video where I will not just list these trigonometry's identities, but I will prove them. You will know how sine square theta comes to be equal to, how sine square theta plus cos square theta comes to be equals to 1. But that will not be in this video, so we treat that in another video. All right, what next I will do is what? I will try to solve a number of what? Trigonometry illustrations, where I will apply this traditional and what? This traditional and alternative definition to basic trigonometric ratios, and we are going to find the reciprocal of these ratios. We are going to use our understanding of the relationship between this reciprocal to what? And the basic ratio to find both the reciprocal and both the what? Basic trigonometric ratio. But this will be in a what? In another video. All right, but here now I will call this video to an end. I believe in this video I'll be able to explain what? The basic trigonometric ratio, the sine, cosine and tangent, and I'll be able to explain the what? The reciprocal, which is what? The cosine, the secants, the cosecant, the secant, and the what? And the cotangent. And also I'll be able to show the relationship between the what? The basic ratio and the what? And the reciprocal ratio. Take this very, very serious. It is very, very important for you to know and understand this. It is something you can never forget as a student of what? Trigonometry. I mean my humble self, Ishola Adedeji Michael. Don't just watch this video. Subscribe to the channel, comment. Feel free to contact me anytime. My phone number is attached to every of my video, including this. Call me, message me on what is related to what I just taught. What if you watch any of my video, you see something you don't understand there, come to my DM. All right, come to my DM, put reference to the video you saw this, and this is what you don't understand and you want me to expatiate more. I will love to. And if you're on your own in your studies, you attempt any question and respect to this and you're unable to tackle it, feel free to share the question with me. I will come rare and I will solve the question, and I will love to what? I will be more than able to share it what? To the world. I am my humble self. Don't forget to subscribe so that when next I make quality content like this, you'll be the first to get notification. I am my humble self, Ishola Adedeji Michael, and this is what? Success Enlightenment. Till next time we meet, stay blessed. Thank you.